Welcome to all the beginners, the student of class 11. Today I will explain the addition of halogen acids to unsymmetrical alkenes or alkynes according to the Markovnikov rule. The Vladimir Markovnikov is a Russian chemist. He gave a rule. According to his rule, when halogen acids add to unsymmetrical alkenes or alkynes, the negative part of halogen acid adds to that double or triple bonded carbon which contains least number of hydrogen atom. This is the rule, and let us take an example. Suppose this is propene, this is unsymmetrical, because if you try to take the symmetry from the middle of this double bond, this will becomes unsymmetrical, so that the halogen acid SBr, and you will get the negative part. The bromine is the negative part and H is a positive part. This addition occurs, this ionic addition, this is the ionic addition, so that you will get the negative part will go to this carbon because it has one hydrogen, and the positive part goes to this carbon. You will get the product 2-bromopropane. This is the Markovnikov product, and let us take another example. For example, CH3 double bond and CH2. This is unsymmetrical alkenes. 2-methyl propene. When the halogen acid adds to this 2-methyl propene, adds to this SBr, adds to this propane, the negative part, this bromine part, will go to this carbon because it has least number of hydrogen atom. If the carbon contains no any hydrogen atom, it is supposed that it has least number of hydrogen, so that the negative part will go to this and the positive part will go to this, and you will get bromine somewhere here, and this is a compound 2-bromo 2-methyl propane is a Markovnikov product. And similarly, if we take the example of the alkynes, for example, this is unsymmetrical alkyne. We can say this is propine, and this is unsymmetrical. It will not symmetrical. So the same way, if we add the halogen acid to this, and the negative part will go to this carbon Br, and H plus will go to this carbon, you will get the product like this, bromine, and triple bond is broken, and you will get the double bond. Again, the addition of bromine will not stop, addition of hydrogen bromide will not stop. Again, now this is also the unsymmetrical. The negative part will go to this carbon, and the positive part will go to this carbon to get the product like this. This is 2,2-dibromopropane. 2,2-dibromopropane. This is the product from this propine, and this is the final product. And let us take another example. For example, now this compound is ethyne. this compound is ethane. This is symmetrical. This is symmetrical. Now at the first step, no problem. For the addition in one position, anyone can go, so that it becomes double bond and bromine will attach to this carbon. Now you look that this compound becomes unsymmetrical, and the addition of halogen acid will not stop. Now this carbon has the more higher hydrogens and this carbon has lesser, and again the negative part will attach to this carbon like this, and double bond becomes a single, and double bond becomes single like that, and H will come here, bromine, again bromine will come to this carbon. You can see this is 1,1 dibromo ethane, 1,1 dibromo ethane is the final product of this ethane. First, this is symmetrical, no problem. One hydrogen and one hydrogen, whatever the addition, no problem. In second step, this becomes unsymmetrical, and then the addition will not stop, so it will continue, and you will get again the bromine this carbon and hydrogen to this carbon, and this is the final product. In my another video, you will get the anti-Markovnikov addition, which is also called the peroxide effect, which is just opposite of the Markovnikov addition. It occurs in the presence of organic peroxide. I will explain it in my next video. Thank you.